welcome to Color -8, your local news channel.
Let's start with our local weather forecast.
Today calls for a temperature of 62 degrees, partly cloudy, with chances of a thunderstorm this afternoon.
To understand the nature of a thunderstorm, you absolutely need to know how they form. Air masses that are warmed from land or water below them are not stable. As long as these air masses remain warmer than the surrounding air, they will rise. Additionally, the air mass will continue to rise until its temperature becomes cool enough to resist uplift. Under these right conditions, convection causes cumulus clouds to grow into cumulonimbus clouds. These three conditions must exist: a source of moisture, lifting of the air mass, and an unstable atmosphere.
I once saw a turtle during a thunderstorm. He would say he was shell-shocked.
Ha. Ha ha. Ha.
There are a couple different thunderstorms. Mountain thunderstorms occur when air mass rises by orographic lifting, which involves air moving up the side of a mountain. Hello? No. Yeah, no, the shipment. I do not want the gerbils and meth today. Do you understand? I do not want the gerbils and the meth today, tomorrow. Okay? How dumb Sea breeze thunderstorms are local air mass thunderstorms that occur because land and water store and release thermal energy differently. Sea breeze thunderstorms are common along coastal areas during the summer, especially in the tropics and subtropics. As land heats and cools faster than water, temperature differences can develop between the air. Frontal thunderstorms are produced by advancing cold fronts, more rarely warm fronts. In a cold front storm, dense cold air pushes under warm air, which is less dense, rapidly lifting it up. A steep cold front boundary. This rapid upward motion can produce a thin line of thunderstorms, sometimes hundreds of kilometers long, along the leading edge of the cold front. Cold front thunderstorms get their initial lift from the push of cold air because they are not dependent on daytime heating for their initial lift. Cold front thunderstorms can persist long into the night. Flooding from soil saturation is common with these storms over coastal land and the air over water. When air rises because of unequal heating of Earth's surface within one air mass, the thunderstorm is called an air mass thunderstorm.
How about let's check on the air fronts around the country?
Amelia, can you explain the different fronts for everybody?
Sure. When cold, dense air displaces warm air, it forces the warm, less dense air up along steep slopes. This type of collision is called a cold front. As the warm air rises, it cools and water vapor condenses. Intense precipitation and thunderstorms are common with cold fronts. When warm air takes over cold air, a warm front forms. When two air masses meet but neither advances, the boundary between them stalls and a stationary front forms. This front frequently occurs between two modified air masses that have small temperature and pressure gradients. Between them spread light precipitation. Sometimes a cold air mass moves so rapidly it overtakes the warm front and forces the warm air upward. As the warm air is lifted, the advancing cold mass collides with another cold air mass that was in front of the warm air. This is called an occulid front. Strong winds and heavy precipitation are common along an occulid front.
How did the boy say he called for dessert during the cold weather? He said ice cream for desert.
Ha. Ha ha. Ha. Jacob, since it's been a bit windy out, how about you tell us about the different types of wind?
If Earth did not rotate on its axis, two large air convection currents would cover Earth. The colder and denser air at the poles would sink to the surface and flow towards the tropics. There, the cold air would force warm equatorial air to rise. This air would cool as it gained altitude and flowed back towards the poles. However, Earth rotates from west to east, which prevents this situation. The directions of Earth's winds are influenced by Earth's rotation. This Coriolis effect results in fluids and objects moving in an apparent curved path rather than a straight line. Moving air curves to the right in the northern hemisphere and curves to the left in the southern hemisphere. Together, the Coriolis effect and heat imbalance on Earth create a distinct global wind system. They transport colder air to warmer areas near the equator and warmer air to colder areas near the poles. Global wind systems help to equalize the thermal energy on Earth. There are three basic zones, or wind systems, at Earth's surface in each hemisphere. There are polar easterlies, prevailing westerlies, and trade winds.
The wind The wind zones between 60 degrees north latitude and the North Pole and between 60 degrees south latitude and the South Pole are called polar easterlies. Polar easterlies begin as dense polar air that sinks. As Earth spins, the cold descending air is deflated in an easterly direction away from each pole. The polar easterlies are typical cold winds, unlike the prevailing westerlies. The polar easterlies are often weak and sporadic. Between polar easterlies and prevailing westerlies is an area called a polar front. Earth has two polar fronts located near latitude 60 degrees north and 60 degrees south. Polar fronts are areas of stormy weather. The wind systems located between 30 degrees north and 60 degrees north and between 30 degrees south and 60 degrees south are called the prevailing westerlies. In the mid-latitudes, surface winds move in westerly directions towards each pole. Because these winds originate from the west, they're called westerlies. Prevailing westerlies are steady winds that move much of the weather across the United States and Canada. Between latitudes 30 degrees north and 30 degrees south are two circulation belts of wind known as the trade winds. Air in these regions sinks and moves toward the easterlies and the easterly direction. When the air reaches the equator, it warms, rises, and moves back towards latitudes 30 degrees north and 30 degrees south, where it sinks, and the process begins again. Do you struggle to tell different clouds apart? Well, here are some key features that will help you remember. Cumulus clouds are puffy, lumpy-looking clouds that usually occur below 2,000 meters. Also, below 2,000 meters, layered sheet-like stratus clouds can cover much or all of the sky in a given area. Some clouds, such as cirrus clouds, often have a wispy, indistinct appearance. A second type of high cloud, cirrostratus, forms as a continuous layer in the sky varying from almost transparent to dense enough to block out the sun or moon. A third type of very high cloud, cumulonimbus, has a rippled appearance, which these newly learned facts you too can tell apart the clouds and be better than your friends that can't.
In the coming week, there are many large thunderstorms beginning to move in our direction.
Did you know that any given moment, there are roughly 2,000 thunderstorms happening around the world?
Isn't that cool?
During the cumulus stage, air starts to rise vertically. The water vapor condenses into visible cloud droplets and releases latent heat. As the cloud droplets begin to come together, they become larger and heavier until the updrafts can no longer hold them, and they fall to earth as precipitation. This begins the mature stage of a thunderstorm.
During the mature stage, updrafts and downdrafts exist side by side in the cumulonimbus cloud. Precipitation, composed of water and ice droplets that form at high, cool levels of the atmosphere, cools the air as it falls. The newly cooled air is more dense than the surrounding air, so it sinks rapidly to the ground along with the precipitation. This creates downdrafts.
Channel of partially charged air is called a stepped leader, and it generally moves from the center of the cloud toward the ground. When the stepped leader nears the ground, a branch channel of positively charged particles called the upward streamer rushes upward to meet it. The upward streamer surges from the ground to the cloud, illuminating the connecting return stroke channel with about 100 million volts of electricity. That illumination, the return stroke, is the brightest part of lightning. There are several names given to lightning effects. Sheet lightnings is reflected by clouds. Heat lightning is sheet lightning near the horizon. Spider lightning crawls across the sky for up to 150 kilometers. Blue jets and red sprites originate in clouds and rise rapidly toward the stratosphere as cones or bursts. Now for a little information on thunder.
A lightning bolt heats the surrounding air to about 30,000 degrees Celsius. That is about 5 times hotter than the surface of the sun. Thunder is sound produced as the superheated air rapidly expands. Because sound waves travel more slowly than light waves, you might see lightning before you hear thunder, even though they are generated at the same time.
Avoid putting yourself in danger of being struck by lightning. If you are outdoors and feel your hair stand on end, the safest thing to do is get inside quickly. If that is not possible, there are steps you can follow to heighten your chances of safety.
Squat low on the balls of your feet. Duck your head and make yourself the smallest target possible. Small sheds, isolated trees, and convertible automobiles are hazardous as shelter. Low spots, such as stitches, provide safety and bring you farther away from the dangers of lightning.
Using electrical appliances and telephones during a lightning storm can lead to electric shock. Stay out of boats and away from water during a thunderstorm.
Following these tips, you can keep yourself and your family safe from lightning. Cools the air as it falls. The newly cool air is more dense than the surrounding air, so it sinks rapidly.
Start the car! Start the car! Dude.
You don't need it. Checks. Have you ever pooped without your phone before?
I haven't.
Exactly.
It's so hard. Let's talk the music cloud.
Stop.
Oh my god, I'm gonna make Pepto-Bismol flavored
Do you want me to throw
Jello.
up again?
Oh,
Throw up on camera.
yeah, throw up on camera for the bloopers.
I need in your camera roll.
Why?
And cools faster than what?
How dumb are
And then it cuts. Hundreds.
God dang it, Evan!
It was doing so good! This is called an ocular crust.
I don't know
Strong winds and
why.
heavy precipitation on the long ocular crust. It takes over cold air and warm air.
Stop moving!
I'm sorry.
This is why! Stop!
Whitney, we.
Vapor consensus, I hate you! What did I do? Whitney, you're over in the background twerking. Oh, as Earth spins the gold. I can't read, I'm sorry.
I'm laughing at the screaming in the background.
That's okay. Where were you just at?
We got.
Moving air curves to the right from the northern hemisphere and curves to the left of the southern hemisphere. Together, the Coriolis effect and the heat and Alzheimer's. Just pause it, and then we'll pick up as if it's a cut.
Yeah.